All right, welcome back, everyone. I am absolutely thrilled to have you here for today's explainer. If you've ever felt like object-oriented programming in Java is just a bit too abstract, well, you're in the exact right place. Today, our ultimate goal is to bring these abstract Java concepts to life. We're going to completely demystify exactly what happens under the hood when your code runs, and honestly, it's going to transform the way you visualize your programs. Get ready to turn those abstract blueprints into tangible, memory-occupying reality. So, here is the roadmap for our masterclass today. We'll start off with the blueprint versus the object, then we'll look at the anatomy of an object. From there, we'll cover creating your first object, explore 4 ways to build, and finally, we'll wrap up with the anonymous object. Okay, let's jump right into part 1, the blueprint and the object. The entire foundation of object-oriented programming relies on a single, super powerful concept. Our code needs to effectively model and mirror the real world. And to do that, we look at 2 contrasting fundamental ideas, right? The Java class and the Java object. On the left, we have the Java class. Think of a class strictly as a blueprint. It acts as a conceptual template that defines data and behavior. It groups related fields and methods together, but, and here is the crucial detail, it doesn't occupy any memory for its fields until it's actually instantiated. It is literally just the plan. On the right, though, we have the Java object. The object is the real entity. It's a specific instance created directly from that class template. And unlike the blueprint, the object is completely tangible inside your computer. It holds its very own state, and it takes up actual physical memory space on the heap. To really ground this theory, let's look at a simple, everyday analogy. Think of dog as the class. Dog is just an idea. It defines that dogs generally have a breed, a name, an age, and a color. But Tommy, the dog, Tommy is the object. Tommy is the actual, living, breathing entity that you can pet and play fetch with. He represents a specific real-world instance created from that general dog template. Moving right along to part 2, anatomy of an object. So, what actually makes up these tangible objects? Well, there are 3 core pillars that give every single Java object its distinct profile in memory. First up, an object has a state. This state consists of the actual value stored within its fields, like Tommy's specific age or his coat color. Second, it has behavior. These are the actions defined through the class methods, things like barking or fetching. And finally, it has identity. Behind the scenes, the Java virtual machine ensures that even if 2 objects have the exact same state and behavior, they have a unique identity that distinguishes one from another. Basically, these 3 pillars allow our objects to accurately mirror real-world items, whether that's a customer in a database or a pair of shoes in an online shopping cart. And this brings us to a super fascinating point about memory. When we create these non-primitive objects, they actually live in a specific area of computer memory, known as the heap. But our program needs a way to find them, right? That is exactly where the stack comes in. The stack holds what we call a reference, essentially a pointer that directs the program to the actual object sitting over on the heap. It's kind of like a digital map pointing the way to our desired destination. Which leads us perfectly into part 3, creating your first object. It is officially time to roll up our sleeves and build your first Java object. We can completely demystify this whole instantiation process by breaking it down into 2 highly actionable, very distinct steps. Step 1 is declaration, where we create that reference pointer we just talked about. And step 2 is initialization, where we actually allocate the memory and invoke the constructor to bring the object to life. So here is step 1 in action, dog Tuffy. I know, it looks incredibly simple, right? But it is vital to realize that at this exact moment, all we've done is declare a reference variable named Tuffy of the type dog. We are completely empty-handed here. The actual object hasn't been created yet, and this reference simply holds a null value. It's basically an arrow pointing to absolutely nowhere. And this brilliantly illustrates the magic of step 2, initialization. By throwing in the new keyword, we trigger a massive shift. The new operator allocates the necessary memory on the heap and actively invokes the dog class constructor. We pass in the specific state, so the name Tuffy, the breed Papillon, the age 5, and the color white. And boom, suddenly that empty reference variable is pointing to a living, breathing object holding its own unique data. Now, pause for a second and just think about what we did. We used the new keyword, which is incredibly common. But let me ask you this, is the new keyword the only way to build an object in Java? Let's find out in part 4, 4 ways to build.
If you guessed that new isn't the only way, you hit the nail right on the head. Understanding these four standard instantiation approaches really separates a novice from an informed developer. So we already know the everyday new keyword. It's for sure the most direct way to allocate memory for standard object creation. But look at the second method here, reflection. This allows for dynamic class loading at runtime, a technique heavily relied upon by massive frameworks like Spring. Then we have the clone method. If a class implements the clonable interface, you can completely bypass constructors and just create a direct copy of an existing object. And finally, we have deserialization. Imagine you saved the state of an object into a file. Deserialization allows you to recreate that exact object from a stored byte stream, reading it right back into memory. Pretty wild, right? All right, bringing us to our final section, part 5, the anonymous object. To wrap things up today, I wanted to introduce you to a very cool memory saving trick. Enter the anonymous object. By definition, an anonymous object is created entirely without a reference variable. Because there's no reference pointer on the stack, you literally cannot reuse this object. It's created, it performs its duty instantly, and then it is immediately ready to be cleared out. This saves precious memory for short-lived tasks, and you'll see it used all the time in event handling, like programming what happens during a single button click on a user interface. So the crucial point is perfectly captured in this code snippet. Notice we don't have a variable at the start, like dog my dog equals. We just say new dog Max, Labrador 3 black, and then immediately call .getName right on the end of it. The object is born, it fetches the name Max for us, and because we didn't save a reference to it, it is immediately forgotten by our program. It's just incredibly efficient for quick, one-off operations. Which leaves us with a really fascinating final thought. We started this explainer by saying that classes and objects are meant to meticulously mirror real-world entities. But if we can create these anonymous, fleeting objects that exist for only a fraction of a millisecond, how does that change the way you think about designing your applications and managing your computer's memory? It's a pretty powerful concept to wrestle with as you move from creating your very first Java object to mastering advanced application design. Thank you so much for joining me in this explainer today, and keep exploring.